All right, so our final problem is a slightly different take. So we're going to get out of you guys' comfort zone with working with things that are geometry based, like rectangles and areas and perimeters, and have you do a little bit more reasoning, but still stay in the theme of quadratic. So as you read through the problem, the basic idea here is it's a marketing question. So this particular college football team has a stadium that holds 50,000 people. They have a current ticket price of $24, and they are now averaging attendance of about 48,000. So they're, clearly they're under capacity. And as any stadium, any team, college, professional, whatever, we'd like to pack the stadium for maximum revenue. So they do a survey, and basically the survey comes back and says that for every $1 decrease in the ticket price, attendance would increase by 2,400 people. So we're trying to do a function that would model revenue based on that marketing strategy that would help us figure out what's the best ticket price. Clearly something below 24, because we got to drop the price to bring more people in. Now this problem is, this function is going to be a little more complicated. The numbers are going to be big enough that this time a calculator would be very helpful. So we're going to switch over to using the graphing calculator here in a second. But before we do that, let's get it set up. First thing for you guys is to try to just understand the revenue model a little bit. And the basic model would be revenue is very simply put ticket price or ticket sales times attendance. So for every $24 ticket that I sell times the number of people that bought that ticket, essentially there's your revenue. Pretty simple model. But for us, we have to incorporate the idea of the marketing concept. So when I drop the ticket price, I increase attendance, and then I also have a base attendance. So how do I roll that all into one revenue model? And first of all, again, it says write it in terms of. So in terms of the ticket price X, so we know right now we're calling our ticket price X, which is what we'll be trying to figure out in a minute. One of the things we'll try to figure out. And so let's start creating the model. So again, the basic revenue model would be ticket price, which we know is X, times attendance. Now I'm going to fill in my attendance here based on a couple things. Number one, I've got a base attendance that is that's a standard right now if that many people are coming. The increase then is an addition, right? So we want to increase the attendance, so let's get it up over 48,000, and how do we do that? Well, the idea is, give you a simple number example. Let's say I decrease the ticket price to $20. Okay, well the difference between 24 and 20 is $4. 4 $1 decreases. So what that means is I could take 2,400 times 4, and there is the increase in attendance. Now also, yes, there's limitations of the stadium, so there's a point at which you're not going to be able to go any further than 52,000. But that's the idea, like how I would set up my model. So the way to set it up then is say I will take 24 minus the new ticket price, which determines how many $1 increments I dropped it, and then multiply it by 2,400. And now I've got myself a decent function that describes revenue for this scenario. Now the next thing to do is go to our calculator and start thinking about how we want to get things set up. So let's get it into your y equals. I'm going to go ahead and get rid of a different equation here. I've already got it in. Give you guys a second to just put it in. Double check everything. I got to go turn it on. There we go. And then next thing is window. So once I got my model set up, that's all about window. And then this is where, again, it's not like the previous problem where pretty much I just ran through and did the work algebraically, but now I got to rely on my calculator, so now I got to understand what makes sense for the problem. So what is the domain? Because when you go to your window, really what the window defines is domain and range. And so now I got to piece that together based on what I read in the problem. So let's go back for a second before we start going crazy on the calculator here and talk about domain a little bit. Now, if 24 is the current ticket price and I'm going to drop the ticket price, then I would know that my domain would realistically be no more than 24. Because the idea is to bring the ticket price down and increase the attendance. Then the question becomes, what's my range? And the range here is based on the y value, which is revenue. Now, if I just took a second to think about it, let's talk about the current revenue situation, right? 24 times 48,000. So I could just do that. And then I could say, well, I'm going to increase the revenue by decreasing the ticket and increasing attendance. So I suppose I could drop it down below that. But also, even better would be, why don't I just take 24 times capacity? Because 24 times stadium capacity means this is the max revenue under the current model if all seats were filled. And I know that my revenue is going to be below that because I'm dropping the ticket price, number one, and I still don't think I'm going to be at capacity, number two. But it's a starting point. So if I take 24 times capacity, it's just shy of 1.25 mil. So here's what I'm going to do. I'm going to go ahead and put in 1,250,000. That guarantees I'll see what I want to see. So there's how I get started. Domain, no greater than my current ticket price. range based on a revenue that I know that I will not be attaining, but it's a place that can give me a nice max to work with. Okay, so now back to my calculator. So 0 to 24. So again, your window is essentially saying what's your domain and range. Maybe 24. Maybe I'll scale by 2 or 3, depends how many tick marks you want. 0, 2, and then again I'm going to go to 1.25 mil. Now as far as scale goes, that's a really large number, so maybe we want to go by, say, 100,000. That's a little more than 10 tick marks, but that's probably pretty good. Okay, so now I feel like I should be ready to go. Like I'm going to see what I want to see. Now, what do I want to see before I go and hit the graph? First of all, is this quadratic? Well, if you got everything cleaned up and multiplied out, you would eventually have x times x, which would be x squared, so yes it is. And then also it would be a negative x squared, which means the parabola opens down. And of course, as you kind of go down through the questions, all of a sudden you see the word max popping up all over the place because you're going to be searching for the vertex. So again, it's good to think about before you go calculator crazy and don't do any analysis, which means you're not relying on your brain. Do the analysis first. Then go see if the analysis matches what the calculator tells you. Okay, now let's see what it tells us. So here comes my parabola as I expected. It's opening down. Now, I'm not seeing the other half. That's because I cut it off at 24. So 24 is out here. We're searching for what's going on in here. Now to the questions. So find a ticket price that would maximize the revenue from ticket sales. So here we go. Let's go find our max using our calculator features. So we're going to go into the calc menu. Number 4 is a max. Get yourself over there. So that flat spot is really the max. It's not really flat. That's just the calculator trying to draw it as best it can, but you can't really do much more up there. So here we go. I'll get a little further over. And yes. Now, in terms of that rounding, that's 22 bucks. So we're going with 22. So $22 is the new ticket price. So I dropped the ticket price twice, which is going to give me 4,800 increase in attendance. And here's the revenue it produces, which is well below the $24 ticket price in a packed stadium, but we're not accomplishing that right now. So anything's better than where we were working. If I did the $24 ticket price times the 48,000, which was the average attendance, that's slightly less than this. So we did at least increase the revenue. And of course, that's what we're looking for, right? Okay, let's go back to the questions for a sec. So 22, what was the max revenue? So 22 produced, again, being careful with what is the max value. Max is not a coordinate. Max is a y value, right? So that's the one we're looking for. And then there's this last question about, before we do the last question, let's talk about graph for a second. So it's very likely that you guys will have to transfer graph from calculator to paper. And what you would need to do to make that accurate, so I would give you like credit for, do you know what your graph's supposed to look like? Or can you explain to me what's being used? Is a couple things. You need to show your max. So here's where my window was, right? Domain, range, and then scale. So that's enough for me to understand what you're working with. And so calculator to paper, this is what you need to show. Now, the last question doesn't really require a calculator if you guys think about it, because here's the deal. What ticket price is so high that no revenue is generated? Well, no revenue generated means that actually, if this graph continues, and I come back down to the x-axis, at this point, 0 revenue. What is that ticket price way out here that's causing me to get no revenue? It has nothing to do with being over here, because over here, I'm on my way up. Here, I'm on my way down. So it's like, well, ticket price here is starting to cause attendance issues. It's too expensive, no one wants to come. And I don't need to do anything with my calculator, I just have to understand a parabola. So at 22 being the y value, 22 being the x value of the max, in a parabola you are exactly halfway through the x interval when you're at the vertex. So I know that it's going to be 44. So in other words, when I get way out here, if this is 22 vertex, I'm halfway through my x's, and it would hit the x-axis at 44. So a $44 ticket price means no one's coming, no one's paying that ticket price. Stadium's empty, no revenue. Okay, so a very different take on a quadratic model, and one that requires a whole lot more thought, I think, than just completing the square and setting up something based on a rectangle. And that'll do it for our notes.